Hello, everybody, and welcome back. So today we're going to learn about OSPF. So we should know about static routes, which are manually input. Once you get beyond a couple, 3, 4, 5 routers, it doesn't do well in large environments. You have really big lookup routing tables because they're static. So router RIP was another one. It's a distance vector, uses hop count, 30 hops. A hop is a layer 3 device, so 30 routers, it will actually expire. eGrip is another review. You should have heard of it. It's a distance vector and a link state, and it uses the dual algorithm. It is the only one that uses bandwidth, delay, load, and reliability. And then you also have a maximum MTU. So if you look inside here, your IP scheme in the center is a 22. So 8 plus 8, that's 16, and then we need 6 more ones. It ends on the 4-bit, increment by 4s. Now let's look at our LANs and WANs. So let's start at HQ. You have WAN on the left, WAN on the right, branch 1, branch a WAN on the left, on the right. So they all have WANs adjacent to each other. On the outside is your LANs. So LAN 1, 2, 3, and 4. And then inside here is LAN 5. And that's where you're using the 22. So if we find .1, actually that's a typo. That should be gigabit 3. Yeah, gigabit 3. .1, you got .2 over here, .3 and .4. These are point-to-point, so the election process is very simple. You know, one's going to be the DR, one's going to be the backup designated router. In here, there's an election process, which we'll cover here shortly. So we basically want to count up, we have 5 LANs and then 4 WANs. So OSPF will build 3 tables, your routing table, your neighbor table, and your topology table. So with all 3 of these tables, it draws a complete picture. It does its own routing table, its neighbor's routing table, and then the complete topology table. So each router has the exact same view of the network. OSPF is CPU intensive to build all the tables. It sends out LSAs and LSUs, link state advertisements and link state updates. It puts a cost on each link, but the way to do the formula, a gigabit, a fast Ethernet, a 10 meg, all look to be the cost of 1. So you'll see that in the reading. So remember, OSPF draws a complete detailed picture of the network. Hello packets are sent to all IPv4 routers using a multicast 224005. And then here's what we want to see what that looks like here. First thing we do is just do a quick audit of the config here. So real quick, HQ has 1, 2, 3, 4 networks. So if I do a show run, so I'm looking at my subnet mask here, because remember, we have to do the opposite. And then down here. So remember, if you share this, it's going to go out and share it. It has a network address, which is the first portion, and your wildcard mask. So 003.255 will be 255.255.4.0. And we could find that up here. So here we go, 4.0. So there's, that's the 7 network. The 248 would be the 7, and 252 would be the 3. So we're sharing 1, 2, 3, 4 networks, and you have 4 networks configured. So if we go to each router, I think we should be similar config. Enable, show run. 1, 2, 3, 4 networks it's sharing, and it has configured 1, 2, 3, 4. And once again, you got should be a 0, 0, 0, 255, 0, 0, 3, 255. And then you can see they match down here. All right, so let's find out, because in this area here, we got to find out who the designated router and who the backup designated router. So we'll do a show IP gigabit 30. So show IP int gig 3/0. So I'm in gigabit 30. This is the IP address .2. It's saying the designated router is .4. And the designated router is .1. So this .4, let's find that on the topology. Looks like it is branch 3. All right, so do show gig 0/0. You got to do the multicast broadcast area. Designated router is .4. Backup designated router .3. So we have our hellos at 10 and our dead timer at 40. So what this is saying, every 10 seconds it sends a hello, and after 40 seconds it will remove that route. So hello means are you there, and if it doesn't answer in 4 times. So if you really want to mess this up, we can set the hello to be higher than the dead, so it will never go up and converge. I did that on accident once, so it was kind of a nice hack. All right, so we know who designated router is. And so from router HQ to branch 1, there's a point-to-point, and the election process happens, but it just picks one. In here, we have a choice. Okay, so first thing you can do is set priority, but by default, everybody's priority 1. So we have to have a number of steps if there's a tie. So if you set priority to 0, then it will be ineligible to become a DR BDR. So if you don't want that to be one of the DR BDR, set the priority to 0. Otherwise, you can set it between 0 and 255. You can set the router ID. And here's your manual router ID. We're going to do this. Whoever's got the highest loopback IP address or the physical address. So none of these have loopback, so it went all the way down to this. And who has the highest IP on 172.16.24 is this 4 number here. So once again, you can see that this router config is sharing networks. Here's your layer 3s. So you can have a hello, a database description, a link state request, a link state update, and a acknowledgement. So we're going to watch these now. So if I'm going to go full screen. And I edit out the filters for you. Just keep OSPF on. Turn a bunch of CDP, DDP, turn those off. So when I disconnect speed up just a little bit. When I disconnect an interface, let's get this over here so we can see. All right, so it sends out, I'm gonna go ahead and pause it right here. So let's look at the first request. It's an update saying interface down. Update. So what would you expect this to be? Update. So we're waiting for an acknowledgement at some point. All right, let's look at these two. Update. Acknowledgement, right there it is. So that's the acknowledged update. So if you let it run, and so that's how they will send out the LSAs, the updates, and also acknowledge, like a three-way handshake. All right, so now let's go in and do this right here. Let's pick the lowest IP, which is just .1 here. So let's make HQ. So we'll do config T. Router. We're using single area, so everything's going to be the same process ID, and that's for local significance. And then we're going to do router ID. I'll do question mark. Okay, it's just the IP format. So let's do 1.1.1.1. Now it says here. So what I'm going to do is now I don't want to leave config, so do clear IP open shortest path process. Now it's saying reset all. I'm going to type yes. Now we can go into the simulation again. And once again, if you let it play out, see it's sending those LSAs out everywhere. So this is why it takes a lot of CPU process when they send out this long. So then eventually it settles in. So do show IP open shortest path. INT gig 3/0. Process ID 111, designated routers .4, backup designated routers .1. So we bumped it into the So that's a way to influence the election process. And then if you do the show IP OSPF, you can see, you can put in the process ID, border routers, database interface, neighbors, and virtual links. So hopefully this clears up a little bit OSPF, and then next video we'll be configuring it.